Good day, everybody. Today we'll discuss on chromium-free iron. Chromium is a metal. Chromium is a transition metal. It is a gray metal. Chromium can be seen on the periodic table. It has proton number 24 and nucleon number 52. This is the position of chromium. It can be seen from your data booklet at the last page of the data booklet. Chromium is an important metal. It is used in the making of many alloys. Chromium is a metal. It loses electron. It reacts by losing free electrons. Chromium metal losing free electrons, becoming chromium iron. Chromium has been oxidized to chromium free. The oxidation number of chromium here is +3. This is the electronic configuration of chromium. 3d5 4s1. When it reacts, it loses one of the 4s electron and two of the 3d electrons. There's a total loss of 3 electrons, and Cr3+ is formed. The chromium exists in the +1 state. +1 means this electron only is lost. It exists in the +2 state. These 2 electrons are lost. It exists in the +3 state. 3 electrons are lost, 4 electrons are lost, 5 electrons and 6 electrons chromium in the +6 state. The maximum oxidation number of an element such as chromium corresponds to the maximum number of electrons available for bonding. In case of chromium, the maximum oxidation state is due to the use of all the 6 electrons, 5 in the 3d orbitals and 1 in the 4s orbital, used for bonding, used in reactions. Chromium free is formed when one of 4s electron is lost and 2 of 3d electrons, 3d5 electrons are lost. Chromium compounds like chromium chloride is green in color. This is a concentrated solution. This is the solution. Some water has been added. This is chromium free chloride solution, aqueous solution, and it contains chromium iron and chloride ion, Cr3+ aqueous. Cr3+ aqueous is in fact CrH2O6 3+. 6 water molecules are bonded to the central chromium ion. Water is a ligand. Water is a neutral ligand. The overall charge is +3 and the color is green. To be more precise, the 6 water molecules are bonded like this. The oxygen are bonded to the chromium by dative bonds, coordinate bonds. It is an octahedral arrangement. It is a complex. The coordination number of chromium is 6 because 6 water molecules are bonded to the central metal ion. The overall charge, the sum total charge, is +3 and the color of the complex is green. How do we test the presence of chromium-3 in a solution like this. The color tells us there's a presence of transition metal ion. But we have to confirm, test its presence, chromium presence. We have to test, either we use sodium hydroxide, where we get a gray-green precipitate, which is soluble in excess of alkali. If we add, instead of sodium hydroxide, we add aqueous ammonia, we'll get a gray-green precipitate is formed, but insoluble in excess of alkali. So I take a small amount of the chromium solution, I add sodium hydroxide solution. I observe carefully. I add sodium hydroxide. I obtain a gray-green precipitate. I add more. Excess means keep on adding until further change. The precipitate dissolves. A green, different green compared to this one. A green solution is obtained. The precipitate has dissolved. If instead of adding sodium hydroxide, we add aqueous ammonia, we take a small amount, and to this we add aqueous ammonia solution. Ammonia solution, care must be taken not to bring it near the nose. Avoid inhaling the vapor. A gray-green precipitate is formed. And we add more, the precipitate does not dissolve. See how much I have added, and when I compare with this one, the precipitate here has not dissolved. This is with aqueous ammonia. Here the precipitate has dissolved with sodium hydroxide. The solution containing chromium, when sodium hydroxide or aqueous ammonia is added, chromium-3 hydroxide is formed, which is a solid and a gray-green color. This shows the difference between the addition of these two reagents. If you add excess NaOH, precipitate dissolves, forming CrOH6 3-. If you add excess ammonia, the precipitate form CrOH does not dissolve. It is insoluble in excess of ammonia. This shows a difference between these two chromium complexes. In the first case, chromium is in a complex which is a cation. In the second case, chromium is in a complex which is an anion. Chromium exists as chromate 6, dichromate 6. Chromate 6 is yellow in color, CrO4 2-, which is an oxidizing agent. Chromium exists as dichromate 6, Cr2O7 2-, which is orange in color and which is also an oxidizing agent. It is used in organic chemistry to oxidize alcohol to aldehydes. When an acid is added to chromate 6, it becomes dichromate. The color changes from yellow to orange. When an alkali is added to a dichromate 6, color changes from orange to yellow because the dichromate is converted to chromate 6. So, in order to test chromium-3, we can use either sodium hydroxide or aqueous ammonia. If we add sodium hydroxide, we get a gray-green precipitate which dissolves in excess. Whereas if we add aqueous ammonia, we get a green precipitate which is insoluble in excess of ammonia. So chromium, a CATION metal, forms plus 3 state ion, chromium 3 chloride, add NuH, gray-green precipitate soluble in excess. It is soluble because of the formation of CrOH 6 3-. This is formed when excess sodium hydroxide is added. Goodbye everybody. That's all from me today. Meet you another time for another lesson.